All right, so we're working on a 2013 Nissan Frontier SV with a 4-liter V6, and we got check engine light on, and also a flashing airbag light, which is interesting. Never seen that before. But check engine light has something to do with the swirl valves was the fault code, and there was also the intake manifold runner position sensor. So I do have them unplugged right now, but I did have P2018 and P2016, and I had one other fault, but basically just circuit faults. So what I was trying to do was I went back with both the scan tools, the Solus Edge and the
You can't see on the.
oh shit.
Just the what everyone's highlighted. I can't read it on the camera.
Oh, okay. Read that now.
Yep.
What I was trying to do is see if I could get a special function to actuate the runners. I guess it would be the swirl valves. When I look up there, it's got a. I'll show you. It's got a vacuum actuated intake runner on the plenum right here, I believe. And then, so inside of there, you'll have like a butterfly flappy things. And
Flappy birds.
yeah, flappy birds, and that just either shortens or lengthens the distance that the air has to travel in the intake, and speeds up or slows down the air. So once it goes through the plenum down to the intake manifold, which is the lower section, there is a motor. I'm guessing it drives a shaft with swirl valves, which is similar to the intake runners, and that's where we have an issue. So whether or not, I know on the 3-liter Mercedes diesels, they were super bad for getting all gummed up, and then they would get stuck and seize, and it would either take out the motor or just wouldn't be able to move, so it would set fault codes. So I was able to unplug them. I had an issue earlier. I was looking up wiring just to study the circuit a little bit and see what I'm gonna get into. And the sensor is a 3-wire sensor, and then the position motor is just 2 wires. But the issue I had was the wire colors were not right. And I did search it up on ProDemand with the VIN, so I would expect it to be right, but wasn't. So we have orange, teal, I guess it would be, or light green, and violet. And on the diagram it was green, light green, and orange. So, you know, 2 of the colors I guess were pretty close, and then I got violet, so I'm not too sure. But I did confirm that the position sensor is back there. And then just on the other side of the intake manifold is the motor, and it's a yellow wire and I want to say a brown or a black, I can't remember, but yep, basically I think what I'm going to do now is maybe check to see with the key on. I'm going to maybe put a test light in place of that motor and see if it does like a cycle test, and check the test light. I'm also going to do some more reading on the strategy of how it works and fill you in on that. So the motor and the sensor are in the back, and there's only maybe an inch or so of harness that the plug is on. So you can reach back there and unplug it. I used my video scope to see where they were, and that was really nice. But as far as testing purposes go, I guess I could use a piercing probe, get back there and get onto the wires, but I don't really want to be that invasive, so I'm just going to go ahead and pull the intake manifold off. Really doesn't look that stubborn to do, so I spent 5 minutes and yank that thing off. That way I can get in there. Taking the purge canister off for the power valve, just so I can access these 10mm bolts. Take the intake off. I'm really curious to see what's underneath, whether these valves are all gummed up, or I have a feeling they'll be pretty clean. But intake off here. Yeah, so if you look down in there, you'll be able to see those valves that I was talking about, them swirl valves. So those are different than your manifold runner valves. These swirl valves, they'll open and close just to change the velocity of air, I suppose, is basically what it does, and that will change the air-fuel mixture for better performance at idle or high speed or whatever. All right, so we got that motor there that drives the shaft. There's two shafts and they're linked together by a linkage in the front. And it's nice to actually have some wires in my toolbox that go right onto those pins nice. And I just got the power probe here, got it hooked up to the battery, and we're just gonna give it a couple little shots and see if this thing moves one way or the other. Yep. So that moved fairly quickly. This setup here is going to be pulse width modulated from the PCM, and basically just turns power on and off super fast. See if you can take a look down in there. All right, so yeah, just take a look down there. You can see it just closed, and then I can reverse polarity to go the other way and open it back up. So I've done that a few times. I know that our motor's working fine. I know that the linkages aren't seized. And now my suspicion shifts to the sensor. So the next thing I'm gonna do is throw the scan tool on there and see if I can find a data PID for that sensor and try to graph it if I can. And then I'm gonna actuate it again. And if I don't have a data PID for that, then I'll probably bust out the lab scope and try to get a graph set up that way so I can watch to see what happens. If it's flatlined, then you know, I'm thinking if I lab scope it and it's flatlined, we probably got a sensor issue. But,
where's the sensor? Show us.
So the sensor is just on the other side. It's right
there.
Right there. Okay, so we just found out that if you cycle the key, they do open. So I had them in the closed position. We cycled the key to the accessory on position, and the valves opened. And then when we cycle the key off and turn it back on again, you can see them just move a little bit. So they default to open when you shut the truck off, probably for starting reasons and whatever, right? And then as you're driving and the engine's running, PCM's gonna control those valves. So next thing I'm gonna do is grab the scan tool, see if I can find a data PID. All right, so I'm just trying to figure out the sensor connector. I believe it has a 5-volt reference, a ground, and a signal. So we got 5 volts.
Far left.
Yeah, which is our orange wire. And then light green or teal or whatever you want to call it. Nothing. And nothing. What? Yeah. So we got the scope set up here, and the violet wire appears to be our signal wire. Then the orange wire is 5-volt reference, and the teal wire is ground, which is the center wire. Just basically have we're hooked up to the motor, so I can power probe it back and forth to move those valves, which they do move. We confirm that. And like I say, we got the oscilloscope hooked up. So I'm just gonna go ahead and flip these back around. And we can see that it does capture that. So the sensor is reading something.
So that first one was the valve opening or closing, and the second one was it doing the opposite because he reversed the polarity there.
Yeah, so now I guess check the wiring harness on the vehicle will be the last thing. and see if we can find anything. What do we got there?
0.42.
1,000 ohms. I was just thinking if there's anything else in the circuit that might be connected. Anytime you do resistance checks, you always have to have the circuit isolated, right? Otherwise, you're gonna have some weird stuff going on.
So here we're just trying to find the same orange wire that's in there.
Yeah, so it is in the purple wire right now.
Oh, sorry, purple.
And I am on orange, so that's no good.
So
Yeah, we can check our signal and see exactly what voltage it is, I suppose.
Yeah.
Just to try to, as a last resort.
So all wires have been ohmed out. They're all good from harness to connector. One thing we're going to go back on is because we have two codes in this, a 2014 and 2017
Yeah, it also had a 2004.
and 2004. 24.
Yeah, 2014 is the signal received by the ECM, the voltage is low, and the 2017 is opposite. The signal voltage received from the ECM is high.
So we're going to double check with the oscilloscope, see what it says. So we're back on the oscilloscope. And it goes from 8 volts to 40.
Yeah.
So that's 8, probably closed, 40 open or opposite. So this is the graph we're getting. Not really sure what the proper values are. Oh, that was a half hit.
Yeah.
There you go.
Yeah, we're not sure the sensor parameters on this one. I would expect, like any sensor I've seen, like pressure sensors, stuff like that, you'd be near 0 for low and almost 5 volts for high, because it's got a 5 volt reference. So how it's getting 40 volts, I don't know.
So we're gonna put a new sensor in this, and then we're gonna re-scope it and see what it reads.
Yeah, I have a feeling it needs a sensor.